I am here to present my work bi-stage QWOA-based efficient feature selection for enhanced depression detection based on facial cues. Depression is categorized by prolonged feeling of sadness for a period of at least 2 weeks, and the cases of depression have been on rise by more than 25% since the beginning of pandemic as per the WHO report. It often drives a person towards committing suicide. And the current methods used for diagnosing depression are clinical methods or the self-assessment method. Clinical methods, clinician interviews the patient to determine his mental condition. In self-assessment methods, a questionnaire is presented to the patient where he fills the questions and we answers the questions, and depending upon the total score we determine his mental condition. Both these methods suffer due from subjectivity, as the patient may be unwilling to share his frame of mind with the clinician, and there may be intentional or unintentional reporting bias in the self-assessment methods. Therefore, there is a strong need for having automated depression diagnosis method for depression detection, which can augment the current ways of diagnosing depression. The automated methods may be based on behavioral objective markers such as facial behavior, speech, text, etc. In this work, we have considered to build a unimodal depression detection system based on facial cues obtained from the video signals. And since the features obtained from videos are high dimensional, hence in this work we propose an efficient bi-stage quantum whale optimization algorithm based wrapper approach for feature set selection and feature selection in 2 successive stages. And we use the popular classifiers linear discriminant analysis and support vector machines in our work. So these are the feature sets, different feature sets that we have considered in our work. These were proposed in our earlier work that is published in Multimedia Tools and Application Journal. These are the 19 feature sets which are extracted using different methods like LBP, HOG, IWBC, and action units, case. And some of these features were extracted from different regions of the face like left eye, mouth, or right eye. And this is the dimensionality, and we can see that the features are actually high dimensional, and if we tend to combine these features then it will further result into high dimensionality. However, initial dimensionality we reduced it using univariate filter method, that is FTR. We selected only top 25 features from these feature sets. Still, the combination of feature sets that is required to enhance the performance of depression detection will result into high dimensional features. So in our work we have proposed a method that does both. First, it selects only feature sets, relevant and non-redundant feature sets, and then it selects from among the features of those feature sets. So this is the bi-stage QWOA approach that we have used. It is a wrapper method as it uses SVM or LDA method to compute the performance of the selected features. So in stage 1, QWOA is used for only feature set selection. The population of size n cross d1, where n is 20 and d1 is the number of feature sets, that is 19, is considered. We evolve it for t generations where t is less than the maximum generations considered. After t generations, we obtain the feature sets that gave us the best result and the second best results, and we take the union of those feature sets and pass it on to the next stage. In the next stage, so the population size will be 20 cross d2, where d2 is the dimensionality of features that we obtain by combining b1 and b2 feature sets. Here, instead of randomly initializing the population, we initialize it using the following method, and we evolve this population for maximum generation minus t. So if we consider maximum generation to be 100, we evolve it for 100 minus t generations. The same is depicted in this diagram, where this is the stage 1 and this is the stage 2. In stage 1 you can see that the population is of 20 individuals and each chromosome is of size 19, which is equal to the number of feature sets, as we are doing only feature set selection in this stage. We randomly initialize the population and then we evolve it for t generations. If maximum generation is 100, out of 100 only for t generations we are evolving this population. After the end of t generations, we obtain a set of feature sets that gave us the best performance and a set of feature sets that gave us the second best performance, and then we take union of these feature sets and and concatenate the features of these feature sets and pass it on to the next stage. So over here, if 6 feature sets were selected, we pass them on to the next stage, giving rise to a population of size 20 cross 150. And then in this we have initialized as per the algorithm shown in instead of random initialization, we have initialized it as per the algorithm shown in the previous slide, and we evolve this population for 100 minus t generations, and at the end we obtain the set of features that will give us the best performance. All the experiments have been performed on the QWOA dataset that is publicly available. It has 2 sets, training and development, each comprising of 107 and 35 samples respectively, and it contains a depression classification labels for each of the samples that using the PHQ-8 method, and we train our model on the training set and test its efficacy on the development set. These are the experimental results. We deliver the performance in terms of F1 depressed score, F1 not depressed score, error, and the number of feature sets selected for stage 1 and number of features selected for stage 2. And the parameters setting for the QWOA algorithm is done as follows. Maximum generation we consider 100. We perform our experiments for 10 runs in order to obtain reliable result, and we deliver both average performance as well as the best performance among these 10 runs. The population size is 20 and the chromosome size for stage 1 is 19, as we have 19 feature sets, and for stage 2 it is dependent upon stage 1, hence it is variable. These are the results obtained. The experiments were performed using 2 classifiers, LDA and SVM. This is the result that we obtained using the LDA classifier. These are the results that are obtained for different set of generations. That is when 10 generations are used to perform feature set selection and remaining 90 generations are used for feature selection. You can see as we increase the number of generations for stage 1, the result of stage 1 improves. However, since the number of generations for stage 2 decreases, the result for stage 2 suffers as we increase the number of generations for stage 1. So there is a trade-off, but we see that the best result is obtained, best average performance among the 10 runs is obtained using when we use 10 generation for feature set selection and 90 generations for feature selection, and the best result of 0.92 among the 10 runs is obtained when we use 30 generations for feature set selection and 70 generations for feature selection. We can see that for both the cases, for the best result, more generations are required for feature selection as compared to feature set selection, as the number of size of chromosome is more for feature selection for in stage 2, hence more generations are required in stage 2. These are the observation, and the similar kind of observations can be seen in when we perform it using SVM. When we perform the experiments using SVM, and the best result and the among is obtained when we set 30 generations for feature set and 70 generations for feature selection. It can be observed that better results are obtained using LDA as compared to the SVM classifier. Here we show that the performance of the proposed method, bi-stage QWOA method, is better as compared to when only a single stage of QWOA was used for feature set selection or feature selection. This is the average performance for LDA and SVM. This is the comparison based on the best performance for LDA and SVM classifier. In both the cases, we can see that the proposed method performs better than the single stage QWOA used for feature set or feature selection. Then this is the comparison with state of the art, where we can see that our method performs much better than most of the unimodal and multimodal methods that are based on video. However, it doesn't perform well as compared to some of the multimodal methods that used multiple modalities. In future, we would like to apply this bi-stage QWA framework to select relevant features from other modalities such as speech and text, which are used for detecting depression, and we can also use it for multimodal systems for depression detection as well as high dimensional datasets in other domains. Thank you.